Hey, Shawn here from 3M. Today I'm here to talk about some issues around weld bonding. So I'm going to discuss weld bonding. I'm also going to do a mock-up repair on these parts here. So this is a little more advanced than some of the previous videos we did, because when we introduce the welding aspect, it brings up a whole host of other issues or problems or concerns that technicians have or things they run into. So I'm going to provide some tips and tricks along the way that should be helpful during these repairs. So I'm going to do some sectioning here, and typically when we're doing a bonding repair or a weld bonding repair, there's also some MIG welding involved in areas we may not be able to access with the squeeze type welding equipment. So we get a lot of questions on, hey, how do I weld around that adhesive and how much of a buffer do I need and things of that nature. So we're going to discuss all that in this video, and hopefully you'll come away from a few new things and tips and tricks. Okay, now that this is secured to the bench, the next step we're going to do is to remove the seam sealer that's hiding the welds. So typically on a vehicle, there's going to be some seam sealer or other things on that area where we're going to have to clean it off so we can identify where our welds are so we can remove them. Now I'm going to be doing some sectioning in this area as well. So in the area that's going to remain on the vehicle, remember this is my host panel, I'm going to remove all the seam sealer from that area and get it nice and clean. The remainder of the area here, all I have to do is remove enough so that I can see the welds. Now, I like to use a Scotch-Brite belt for removing the seam sealer because it doesn't get too aggressive and actually remove some of the steel and disguise where the welds are. All you're going to see are scratches. Whereas with this Scotch-Brite belt, it's actually going to highlight those welds and really bring them to the forefront so you can see exactly where they are. It's almost like a guide code in the center of that weld that's going to identify where they are. We're going to need to know exactly where those welds are because we're going to have to replace them adjacent to the existing area for squeeze type welding, and we're going to replace them right at the weld site, the original weld site, when we're mag welding. So I'm going to remove this seam sealer and we'll go from there. Okay, so I've removed the welds from this area here. You'll notice I left the last two in down here because this is going to be the area I'm going to section. So I'm going to identify my sectioning area and mark it with tape. So I'm keeping it simple here, and I'm just going to use 2-inch tape. Obviously, if we were sectioning according to a manufacturer's procedure, typically they're going to tell you measure 80 millimeters back from this joint or this landmark on the part, but here we're just going to use 2-inch tape to identify where that sectioning line is going to be. So on this particular repair, we're going to weld bond on one side and mag weld on the other, and then mag weld our joint shut. Now our replacement panel, we've got to identify the marks in the same area. So again, I'm going to go 2 inches back with the tape. Strongly suggest that when you're working on a vehicle, it's a good idea to put some markings or identify what you're doing in that particular area. So in this case here, this part here is my replacement, so I'm going to write scrap on here, and I'm going to write scrap on this part. And then this is save here and save here. So I know this part is going to replace this piece here. So the next step here, I'm going to take my cutoff wheel and I'm going to cut as far through this as I can using my cutoff wheel. Okay? Now the difficulty we're going to run into here is that I can only cut so far with my cutoff wheel before I start cutting into this bottom flange. And the key to this repair is not to damage the bottom flange on the host panel. Again, if we cut through that part, it may have to be replaced. Sometimes they're ultra high strength steel. Once you cut it, it's done. You can't weld it. So we have to be very careful about cutting through that bottom piece. So I'm going to cut as far as I can, and then from that point I'm going to show you a new technique that we've developed using the file bell tool that we call a plunge cut. So let me cut this first with our cutoff wheel. Now, as you can see, I could only go so far with the cutoff wheel. If I cut any further, I'm going to go and damage that bottom part. So, as I mentioned, this is what we call a plunge cut. So what I'm going to do here is I'm going to cut from two different angles. This is very important. We want to cut from one angle so that we don't catch the belt. So on this surface here, I'm going to cut from this angle, and I'm going to grind until I expose a little window, cut a little rectangular shaped window there. Then I'm going to actually expand that window sideways just a little bit so that I can come from this angle and finish the cut. So I'm grinding that instead of cutting all the way through it. So this way I avoid damaging that flange. Okay, as you can see, what I did is cut the spot welds, and then I plunged in with my file belt sander to expose a hole here. Now, the reason this is also important is typically there's going to be some kind of a reinforcement fairly close underneath the top layer. So we run into that situation a lot, like on rocker panels in areas such as that. So if there's a reinforcement there, again, we can't go all the way through with the cutoff wheel. So I ground this down. I ground as far as I could here, and then I slipped this plate in underneath so that when I made my final grind on the bottom, I didn't grind the bottom plate or the host panel. I ground on this piece of steel here. So you can see I have a nice clean cut here, and I did not touch that bottom panel at all. The other thing that's advisable is to maybe cut this just a hair larger, a little bit longer, and then grind that back when you go to make your final fit for your sectioning joint. So I'm going to cut the other side of this, and then we'll continue on with the next step. Okay, so to this point, we've got this cut off, and as you can see, there's some difficulties. It's a little more difficult when there's adhesive or sealer in the joint for sure. That's going to make it harder to cut the welds and separate everything apart. Got to work at it a little bit, come at it from some different angles so you don't tear the metal. But again, the object is not to damage this bottom panel, which we did a good job on. So I've got a nice clean cut here, a nice clean cut here, no damage to the bottom. I can still see material remaining from the welds, so I didn't go too deep there. Now the next thing we're going to do is remove all the seam sealer and the weld nuggets here to have a nice flat surface that's prepared for that adhesive. The other thing I need to do as well is cut this replacement panel, because I'm going to use this part as the replacement and scrap this piece here. So I'm just going to clamp it onto here temporarily so I can make my cut, and then I'll take that off and that'll be ready to go as well. So again, I'm going to gear up here. We're going to clean everything off, and I'll probably touch up my sectioning line here just a little bit so we get a good fit. Okay, so at this point here, what I've done is I've ground this flat, cleaned up any contaminants that are in here, and again, on a vehicle, we're going to see adhesive, seam sealer, e-coat, corrosion. All of that has to come off and down to nice, clean, bright steel. Our replacement panel is cleaned off and ready for adhesive as well. I did some preliminary fitting here. It fits pretty good. I've got a nice tight gap. As you can see, I turned my roll-lock disc a little bit sideways here, which allows me to get right on that joint. You know, there's some areas where it's a little awkward to get at, partially because I'm trying to stay out of the way of the camera here, but you know, use good angles so that you're grinding the correct way so that you're not catching on the edge of that panel as well. We can always use a clean and strip wheel as well to clean these areas off. I use the file belt tool because primarily I'm doing a small area. If I was doing a really large area like a roof skin or a van side or something really large, this tool really cleans the adhesive or whatever that's on that surface very, very quickly. So for speed, I always use this in large areas. So now the next thing we have to start thinking about is our welding situation here. So like I mentioned, we're going to operate as if this was a vehicle, where typically there is some mag welding along with the squeeze type welding. So I'm going to choose to mag weld on one side or the other here, and I'm going to mark it up. So I'm going to mark this piece here. So this is my mag weld side, and this is my squeeze type resistant spot weld. So these are marked. I'm going to do the same on the panel on the inside here so I don't remove it. So this is mag, squeeze type resistant spot weld. Okay, so those are marked. And the next thing we also need to think about is cleaning the surfaces for welding. So because this side, the squeeze type welding, I'm going to need both sides cleaned. So anywhere these tips on the welder touch, I'm touching clean metal. On the other side, I'm going to have to punch some holes. And do I really need to clean the back side of that? Not necessarily, but what's going to happen if I don't is the paint's going to char, and we're going to end up cleaning that off anyway. So I'd rather just clean that off from the beginning. The other thing we have to start thinking about at this point is cleaning where we're going to mag weld this open butt joint we're going to use here, even if it was a butt joint with a backing. So I have to clean these areas here, because anywhere I'm welding, I want a nice clean surface. The other thing we're going to have to talk about coming up here is the Weld-Thru primer application as well. So for now, what I'm going to do is mark my welds, clean off where I'm going to weld, clean both sides of the material, and punch some holes for my plug welds. Okay, so now we're to the point here where everything is cleaned, and you'll notice as I was working, you probably noticed I cleaned, I missed one spot here. So we always have to double check what we're doing. So I got to clean a little bit on this side here. But we've got both sides cleaned, the inside cleaned here. And the main reason is we don't want to contaminate our weld. So when we start to MIG weld or mag weld on here, if we have paint in the way, we're going to get a poor quality weld. We're going to get all kinds of fumes, and really what happens is the paint that's remaining here will also char and burn. And later on, after the end of the repair, and we put cavity wax in here, if you spray it on charred, burnt paint and loose paint, it's going to fall off, and you're not going to have that corrosion protection. So we want to have nice clean metal there. Some of the manufacturers may recommend epoxy primer in that cavity first before the cavity wax. If they recommend that, obviously go ahead and do that. But oftentimes they don't, because they really, the epoxy primer, there's curing issues, and it can actually cause more problems than it does good. So bare metal works very well as well in there if they don't recommend it. So I'm going to have to continue and clean this one spot. Before I do, I'm going to mark where my welds go. So this side here, we're doing mag welding. Mag welding, we always want to weld in the exact same spot as the previous weld. So I'm going to mark where that is on the side here, so that I can punch my holes in the correct spot. On the other side, where we're squeeze type welding, we want to weld next to the previous weld. So 1/4 inch or so off to one side. because the metal generally has been thinned in that area, or it's been work hardened from the heat of welding. So they want us to offset that just a little bit in most cases. Now, a lot of the OEMs have very specific information for squeeze type welding. Number one, you have to have the proper equipment that generates enough amperage, enough squeeze pressure, and fits their requirements. Some may also want you to weld on manual settings rather than automatic settings. So always consult the OEM information for that kind of stuff. The other thing is they may have very specific information. For example, Nissan tells you to add 20% more welds when you're spot welding it back together. They may tell you the spacing between the welds, and they may tell you the size of the weld nugget that has to remain when you make that weld. So all those things need to be considered when you're squeeze type welding. But we've got this marked off now in the proper area. I'm going to go ahead and clean this area that I forgot here, and then we'll go back and we'll apply our Weld-Thru primer to a test fit, just to make sure everything fits up, and then we're ready to apply our adhesive and start welding. Okay, so now we're at the point here where we're ready for Weld-Thru primer. My suggestion is punching your holes first in the designated spots that we already marked, then applying your Weld-Thru primer, and then doing your test fit. And the reason is you always want to weld on clean bare metal. And if we don't clean the bare metal from the center of the plug welding holes, we're going to get contaminated poor welds. So a lot of guys have different techniques or tricks for cleaning that out once they apply the panel on top. They use little bits or little wire brushes or whatever, but I'm going to show you a way that's a little bit easier using the file bell tool to clean those weld zones where you don't have to use a spot blast or something that's a little trickier to use. So I'm going to punch my holes here in this part, and then we'll get ready for Weld-Thru primer. So I'm just going to mask this area off just so I don't get Weld-Thru primer all over the place. Now on my area here where I'm going to squeeze type weld on this side, I don't need Weld-Thru primer. I obviously don't want it anywhere there's going to be adhesive. However, because we're doing an open butt joint and a mag weld, a continuous mag weld in this area, we want a little buffer zone here between where we're mag welding and the adhesive as much as we can. So I'm just going to put a little piece of tape in this area, just about an inch, just as a little buffer here, so we don't have to mag weld too close to our adhesive. It'll burn, it'll run into the weld zone, it'll smoke, it'll cause all kinds of issues. So we don't want to have to deal with that. Now Weld-Thru primer is a unique product because it's got a lot of solids in it. So about a third of this can is full of zinc powder, and that zinc powder tends to settle down to the bottom of the can. So we want to agitate this can really well before we spray it. I actually shook it a little while ago to get it going. Now, we also recommend for storage, maybe storing it upside down, which I see some technicians do, which is a great idea, or even on its side. But either way, the solids won't just settle on the bottom, and when you pull the actuator nozzle, just suck up solids and plug everything up. So if you have trouble with cans plugging up, that's what's going on. So you want to agitate them really, really well. So like I said, I shook this up a little bit already. Shake it up a little bit more. Now I'm going to apply the Weld-Thru primer only to the side where I'm doing my mag welding. Obviously, we don't want to apply it anywhere we're using adhesive. So this product requires 2 coats. I'm going to let this one flash for a minute and then spray my second coat. So it's already to the point where it's flashing off. Okay, my primer is now flashed off here. Now what I'm going to do is remove my masking tape. Oops, I leave that one on. And now the important part here is that we never want to weld over the top of Weld-Thru primer. So although the name says Weld-Thru primer, it needs to be cleaned from the immediate weld zone. In other words, we have to clean those plug weld holes out. So the easiest way to do this is to apply your Weld-Thru primer after your holes are punched. Then you test fit your part. You've got to test fit your part anyways, right? So if you're working on a quarter panel, you're going to test fit it, dry fit it, put it on, make sure all your gaps are okay. Then you're going to take it back off to do your adhesive. So while we have it on there for our test fit, now what I can do is mark these holes off with a marker. And now I can go back and hit these little spots with a file belt sander and clean them off so I'm welding on nice clean steel. Now that might seem like a little extra work, but actually it's very quick. And now I've got nice clean steel, so your welds are going to weld better. They're not going to be contaminated. You're not going to get as much spatter, and they're going to be cooler welds as well. So just a little bit of planning ahead and cleaning those out is going to make your life much easier when it goes to finishing your welding and grinding your welds. So now that's all prepared. Next thing we need to do is prepare this side for our adhesive. So the first step in applying any adhesive is cleaning. So we want to have a nice clean surface. So a VOC compliant cleaner in wherever your zone is. I'm going to apply this nice and wet, wipe it off, and it'll give us a really good bond. So the trick with an adhesive is that it wets out the surface, so you get a really good solid bond that's not going to peel or fail or whatever later on down the road. So having it clean, very, very important. Okay, so I've cleaned that surface, and while that's flashing off, I'm going to prepare my adhesive cartridge. I'm going to use impact resistant structural adhesive 7333 for this particular repair. This is the point where, though, we always have to go and consult the OEM information to see which adhesive they recommend. It depends on the year, make, model, and part of the car. They may recommend a specific adhesive for that application. They all have slightly different clamp times as well, so we're going to have to worry about our clamp time. So there's a 4-hour clamp time for 8115, 6-hour clamp time for 8116, and an 8-hour clamp time for the structural adhesive. Keep in mind though, you can always accelerate with heat and shorten that clamp time as well as the cure time. So I'm going to prepare this cartridge by equalizing. Always a must to equalize that cartridge. Make sure the plungers are balanced so you're not getting more than of one side of the product than the other. This can be done into a paper towel. And we're just looking for a little bit of product to come out of each side to see that neither port is plugged. Once it's coming out nicely, I can attach my mixing nozzle. And then we'll also extrude a little bit out onto a piece of cardboard or paper towel, a couple inches, just to make sure that we have a good adequate mix there. Okay, so the surface is cleaned, I'm ready to apply this. And as always with our adhesives, we do 3 applications. So 1 application on the host part, 1 application on the replacement part, spread those both out, cover all the bare metal, and then a 3rd application, which I call the squeeze out bead, which ensures you have enough material to get good squeeze out. So I stopped short on this edge a little bit to keep that 1-inch buffer between where I'm going to mag weld that seam. This side here is masked off for that same reason. Got to cover all the bare metal so we don't get corrosion issues later on. Now I'm going to apply again what I call the squeeze out bead. And you could do this on either part, post panel or replacement part, but you only need to do it on one piece. I'm going to use a pretty small bead because these pieces are perfectly flat. Normally on a vehicle I'm going to use like a 1/8 to 1/4 inch bead. Now that I've got my squeeze out bead on there and my other side covered completely, I can mate these parts together. Again, notice the gap where there's no adhesive here, so I don't get it in this area where I'm going to weld. So I can take off my masking tape. I've got a 1-inch buffer on both sides where I'm going to weld. I can attach my part. I've got clean metal over here in my plug weld holes. You're going to get some squeeze out, which is a good thing. So we want to have some material squeeze out of that area. That means that we've completely filled that joint for corrosion protection purposes. You can use a number of different style clamps. You could use these types of clamps. You could use these types of clamps here. Some guys will use some little thumb screws. Whatever you want to use is fine, but you have to clamp it securely. Now, can you over clamp this adhesive? Virtually you cannot, unless you just went crazy and had a clamp every 1/4 inch. But if you space your clamps a couple 3 inches apart, you should not be able to squeeze too much of the adhesive out because it's got glass beads, 10 mil glass beads inside that will basically make it impossible to over clamp. So clamp it tightly, especially when we're squeeze type spot welding. We don't want to be drawing those panels together with the pressure of the machine. We want to already have them tightly fit up, because if you use your welder as a clamp to pull the panels together, that's where you get holes blown through the panel. Once that weld nugget gets hot, the panels will spring back open, you'll end up with a hole. So we want to clamp those down nice and tight. Let's put one more clamp in here. Okay, so all clamped up. Now at this point, you could either do your spot welding or your mag welding first, but I'm not going to do the mag welding for the purposes of this demonstration here. I'm just going to show you what it looks like, and we would continue and mag weld this. We would mag weld our seam shut, and then we'd be ready to finish with the squeeze type welding. Okay, so now at this point, I'm all clamped up and I'm ready for my welding. This is the time where we're going to really want to look at the OEM procedures and see if they have any special recommendations. For example, Nissan says to add 20% more welds. Sometimes they will give you the weld spacing, how far apart they want the welds. They call that pitch, or the size of each weld nugget. So we really want to look to see what the OEMs recommend as far as the exact details for the welding. They also may have some equipment requirements. So make sure that your equipment is adequate to weld through this adhesive as well. So once I have this clamp together, which I do, the other thing I've done is I've added a shunt clamp on here. This shunt clamp is used because there's adhesive in the joint, and that adhesive is insulating the top panel from the bottom panel. So to get good electrical conductivity, I want to put this clamp on, which has a cable that goes from one side to the other. So now this is all ready to go. So I'm going to put on my respirator here and my shield, and I'll make a few welds. So as you can see, the welds have been completed. We have good squeeze out of adhesive coming out of that joint is what we're looking for. At this point, we would finish the repair, right? So things you guys do every day, we would weld our sectioning joint, we would plug weld our plug weld holes shut, add any foams that need to be added, that should be added after the repair, such as a dog leg or a quarter panel or a rocker panel. And then finally finishing up with cavity wax. We always want to protect that repair from corrosion. So that really completes this exercise here. I did want to show what our ultimate goal really is in a repair would look something like this. So all the welds are complete, my joint has been welded up, and there's actually cavity wax installed inside this particular part. So this is really what we're looking at on a vehicle to complete the repair is what we would look like here. So thanks for joining us today. Visit us at 3mcollision.com, or you can see us at 3M Collision Repair Academy. So thanks again for joining us. We'll see you next time.